let me just dive in a little about myself. Tracy already mentioned that I work at CloudBees. CloudBees, I wouldn't be surprised if you had not heard of it, but we make Jenkins. That's our open source product. So if you've used Jenkins, you've used software that we've written. We also have a enterprise version of this if you're trying to make Jenkins scale. Check us out. We are hiring. We're looking for Java developers, I think, and QA people right now. Oh, and Jenkins, you may be familiar with its interface, is kind of terrible. Now, I happen to be a UX designer at CloudBees, but I just joined, and we have a new initiative called Blue Ocean. You can learn more about it on the Jenkins website, actually, but you can see a live running instance of it at blueocean.io. There's some really cool stuff going into the UI that we're hoping to ship soon. Before I get too far here, just a modern web announcement. This is the Slack channel if you want to join. Go to slack.this.co. That's very hard to say for some reason. The source code for this presentation is on GitHub, so you can visit that at this link, and you can follow along with the presentation at this link, okay? Now, I know I've just given you 2 links in a row. Here's the link to the presentation, big red arrow there, while I talk through the next slide. I would encourage you to check out the code. It might make it easier to follow what we're talking about. So D3, why D3? So D3 is a robust data visualization library. What do I mean by a robust data visualization library? Well, it can do charts. Let me show you some examples here. I guess I got to get out of this for a second. Okay, so you can learn about D3 at d3js.org. It's really cool. Click on the examples link, and you can see some of the things that people have built with D3. As far as being a data visualization library, it is completely generic in some ways as to the types of charts and things that you can create using its components. I thought I would give you kind of some examples. This is one that I've worked on, more of a timeline series chart where you have a bunch of different events with different values taking place over time. So you can do things like bar graphs and boring stuff like that. You can also let me see if I can make this smaller. Yeah, here we go. You can also do some crazy stuff with like geolocated data. Coloring and maps with different things, and then you can even go more crazy. This is making interactive stuff. So in this graph or series of graphs, you can dive in to it and kind of explore what's going on in these little bubbles there. And this is all done with D3. So it's really good for doing kind of interactive stuff in that regard. Anything that involves, drawing, that type of thing. I have done, your traditional stuff with it, but I've also played around with, more interactive. This is just an illustration of Bezier curves. If you play around with SVG, this is probably the hardest thing to understand. But I created this sort of interactive drag handle type view all in D3. So there's some fun things that you can do with it. It happens to make most of the chart for the math that you're working on to build a chart pretty trivial. A lot of really challenging stuff becomes very easy with D3. It helps you build, in particular, it can translate between different values, which is helpful when you're doing graphics. So you can translate between the values that are in your data and where that pixel should be on the screen. And D3 is probably the thing that is underneath the charting library that you're using, if you've used a charting library. Most charting libraries are built with D3 because it just happens to be so awesome. And, of course, there's tons of examples. A lot of times what I would do starting a site or trying to build a graph, I would just go find the example of the thing that I was trying to build, and then I'd take it apart and customize it. So some great stuff on the D3 website there. And it's also, believe it or not, a lot of fun to sit down and learn. It has a very simple API as far as a library would have. Pretty easy to grasp, and it's also a little bit mind-bending, the types of things that it does. And the way that it works, it's a little different from your standard DOM manipulation libraries. So I wanted to talk about just creating a regular old SVG image in D3. How would you go about doing that? So before I get into this, jQuery. Everybody used jQuery or have some familiarity with jQuery? Okay. So jQuery, of course, is a way of manipulating what you see in your HTML, attaching events, things like that. At its very simplest, D3 does offer some things that are similar to jQuery. So here we have a D3 selection being created with the call to select. So in one sense, if you're doing jQuery, this would be the jQuery object that you would get back. Not the actual HTML node, but there's sort of a wrapped object that you get back as a result of using D3. So here, all I'm doing is grabbing the ID of the thing that's the smile div, I guess, that's in the DOM, and assigning it to L. But after you do that, you're going to want to add stuff into the DOM. So very similar to jQuery in terms of adding new elements and things here. We're appending an SVG element to that simple div. We're going ahead and setting the attribute width to 100, the attribute height to 100. And then going a little bit further, let's also add a circle element inside of that SVG graphic that we created. So here we are. We're selecting the div. Here we're creating the SVG wrapper, and here we are appending an SVG circle to it, setting some attributes on that, and it gives you something that looks like this after you get done with all of those calls. And like this when you look at it in your browser. Is everybody sort of tracking with me to this point? Okay, so let's take this a little bit further. Here we go. I'm going to draw another ellipse for a left eye, and then another ellipse for the right eye. Again, we're just using simple append calls to put it inside the SVG graphic, and then setting some attributes on that thing that comes back, the D3 element thingy. That's the official term for that thingy. So, and then here we're actually drawing a line for a smile. Anybody know what we're building yet? And of course, I'm sure that you can see that this attribute for the path here is drawing a nice, beautiful little smile arc, right? This is the hardest thing to me about learning SVG is getting into the arc syntax. You don't need to know that in order to have fun with D3, but it does make a pleasing demo, a smiley face. Okay, so what I've just shown you is how you can use D3 to manipulate the DOM and build things with it. You can build SVG with it. You can also build HTML with it. You can select HTML elements. You can attach events, things like that. But there's this other piece of D3. D3 is not a replacement for jQuery for most websites. what it does really well is bind data to the DOM, and particularly when you have data that is changing. For instance, you might want to have a bar graph that kind of animates. Maybe it's hits that are coming in on your website or whatever it is. You want to show that in a kind of bar graph. So that's what we're going to build today. So to get an idea of what data binding is, at its very simplest, here we are binding a simple array to a selection of circles. To a selection of circles. So one of the things that's kind of backwards about the way that D3 works, and it's a little mind-bending, is that when you're creating new elements, you do this thing where you select all the elements that don't exist yet, and you bind data to it, and it's called a selection. So in this case, what I'm sort of saying is that there should be a circle element in the DOM for each little piece of data that I have put in the DOM, okay? Or that I've bound to the selection, I should say. So here I have this selection of circles. Nothing is in the DOM just yet. But now I'm saying inspect the DOM on the enter event, and for every piece of data that doesn't have a circle representing it, go ahead and append a circle to the DOM. So that's what this is called, an enter selection. And then for each piece of data, I'm using the attribute here, the attribute setter, but instead of passing in a number like you can see I'm doing for the CY, instead of passing in a number, I'm passing in a function. So the size of the circle, in this case, the radius, is determined by the value of the data times 5, is what I've just declared there. And if I was to run this, and then I've got some positioning logic in there. If I was to run this, I end up with something like this. So you can see here, if I go and look back at my data array again, I have 1, 2, 3, 2, 1, right? 1, 2, 3, 2, 1 is the way that it's spacing it out. And this is the really brilliant thing about D3. It's mapping that and binding that data to a representation in the DOM. And I've declared it in kind of an abstract way here, right? But it's being applied to every one of those circles to set their radius and their position and things of that nature. So it's a very cool little library. Let's look at how we would build a simple bar graph with something like this. So for our purposes, this is going to be more of a sparkline bar graph. But D3 gives you the tools to like build axes along the graph and label things and whatnot. But in our case, we're just going to draw the bars themselves. So the basic properties of our graph, I'm going to go ahead and define these. It's going to have a width of 200. These are just some variables that I'm going to use later on. I'm defining how wide I want my bars to be, how high the graph is. So the graph is 80 pixels tall, 200 wide. The bars are 8 pixels wide. Half a bar is half the bar width, 4 pixels. And the color of the bars is Dodger blue. Then I'm going to define my graph, just so that I have something fun to play with to begin with. Each one of these numbers represents the height of the bar in this case. So in your data, it could be the number of page hits, whatever it is that you're trying to draw a graph of. That number would be plotted there. You could also use regular JavaScript objects in here and include things like the date or the time that something had taken place and use that in your drawing. I'm still just using numbers here for this simple little graph. And then I'm going to do something here. D3 is very functional oriented, and a lot of times you find yourself in D3 calling a function that creates another function. So these two min-max functions here are going to return, in this case, the maximum value. I'm sorry. I'm going to get to the functions that create other functions in a second, but the maximum value of the data, and then the minimum value of the data as well. And I'm going to use 0 just in case data, I'm going to add that into the array just in case data doesn't have that. So this should give us a consistent height for all of our elements. So we have our min, our max, and then the length of our data, however many bars we're going to have. I want to go ahead and capture that. So back here, remember we defined our data. Here, grabbing the min, the max, and the length of the data, how many items there are. Now here we have this thing that creates another function. This is called a D3 scale. And D3 has a bunch of different kinds of scales that can be used to translate coordinates into things on the screen. The linear scale is one of the simplest. And basically what it does is it allows you to specify your min and max for like your domain, and then the range of value. So what is this actually turning into in this case for this scale? So in this case, you can see that the domain numbers are coming in there between 0 and 20, and then I want them to be drawn on a scale of 0 to 100, if that makes sense. So in this case, this would be great for a graph that was 100 pixels high, right? You want those bars to max out at 100 pixels high. So I've created a scale. So now once the scale, it creates that little function for me. And it could be loosely translated in this case to 5 times whatever the factor is equals 25. So we can do that math in our heads, right? And 5 is what? 25% of 20, right? So on a scale of 0 to 100, it would be a 25, right? So that's all that the scale function is doing. It's just giving you a way of quickly mapping those coordinates. The great thing about D3 supplying this stuff for you is that this could be the height of your browser window or whatever it is that you want to translate coordinates across, and it's just doing the math for you automatically. All right. So the next thing with that is we're going to create a linear scale for the x and the y coordinates, and this is very similar to what we did on the other thing. But I'm doing a few calculations just to set the on the x-axis, set the bars equally spaced from one another so that they span the whole graph, and then on the y-axis. So that they go to the height, right? So we're looking at from 0 to the height of whatever the graph was that was defined. So here, we're going to just do the last bit of the work, actually draw it, now that we have our element or our functions and things set up. So our chart, we're going to select the div that has bars. We're going to go ahead and create the SVG with the width and the height, based on our variables, whatever those were. Then we're going to bind the data to this selection. Okay. And then we're going to append the new bars. And here we're using our x and y function that we created in the attribute assessors to do the calculations based on the data that's being passed in. So in this case, for the x function, there are 2 parameters. The second is the index of the bar in the array, essentially. So I can use that to equally space out my bars along the x-axis. And then on the y-axis, I can determine where I'm going to actually place it on the graph. And it's a little weird because, SVG is set up to draw, I think, is it reverse coordinates? So 0, 0 being the upper left corner. I think that's right. So our y is constantly changing for each of the bars that we have, depending on its height, right? So that's what that math is about. And then we have the height of the bar, which is just y times passing in the data. So it calculates that for us. So given that tiny little bit of code, in some ways, it's able to produce something like this, a complete bar graph. Are people tracking with me? Am I blowing your mind yet? Okay, we're going to keep moving. I only have a short period of time here. So the next really cool thing that you want to do with it is to update it and animate the bar graph. So the way that you do this, we're building on everything that we've just learned, is there are two different kinds of subselections. I've showed you the enter subselection. The enter one gets called when you add new elements for items, and the exit one gets called when you need to remove an item. So you might have this array of things, you're updating it with new values, and based on those new values, things pop in and out of the DOM, pop into existence and out of existence, right? So when they pop into existence, you should have an enter selection that does some work on that. When they pop out of existence, you probably have an exit. I think by default, D3 will just remove it, but you might want to animate it out of existence or something like that. So that's what exit's helpful for. So let's look at what they call the D3 update pattern. The first step is you bind/rebind data with the select all and the data functions. Second step, you add new elements with an enter subselection. Third step, you update all the elements in the selection. So we add new elements, we update the existing ones, well, all the elements actually, and then we remove the unneeded elements with the exit subselection. So this is everything you need to do in order to take a graph from one state to another state. This is the D3 update pattern. So let's look at what this looks like in code. So I'm going to be building this update series being the new data function. And I'm going to show you the four parts, the bind, the creating new bars, the updating all the bars, the removing the unneeded bars. So again, this is the same code that we had in our last graph, just to make calculating the min and the max easy, grabbing the length, doing the scales. It's the same code. All right, so how does this look when we use it in real life? We've got our selection. So the first thing is to bind the data. We've got new data coming in that we need to associate with the DOM node. So in this case, we're selecting all the recs that are in our SVG, and we're binding the data series to the recs. So that's the first thing. You bind the data. The second thing is the enter subselection. And there's generally only a few properties that you need to worry about in the enter subselection, because you're going to get to it with our third thing. So the only thing we're worried about here is to go ahead and set the bar color, go ahead and set its width, and append it to the DOM. So here we've got a rect. We're adding a new rect in. And again, what this is doing is any new elements in our data coming in, our series, will get their own rect if there are new data points. So then we write on the selection itself, we write, which again, if we back up, the selection is just the set of all the recs now that are on the screen. We've added the new ones. Now, all the ones on the screen, we need to reposition their x, y coordinates and their height. So this is most of the code that I explained earlier, just calculating the x, y, and the height. But in this case, we're applying it to the entire selection, not just the elements that just entered on the screen. And then we write a very simple exit selection. This is kind of redundant to just call remove, but you could animate these bars down or do something like that in order to remove them from the screen. So that's it. Our 4 steps to bind, rebind the data, create the new bars if needed, update the size and position of all the bars, and then remove any unneeded bars from the screen. And after you do that, we can write a tiny little bit of code to just push a random number into our data and call the update function with the new data. So here we're shifting one off the back, putting a new one on the front, and with that little code, you get an animated bar graph sliding across the screen. Isn't that cool? And that's it. That's all I have tonight.